So if you've been paying attention to the last few videos, I hope you're impressed with this nebular hypothesis, because sort of when I get to the state of this discussion, I just can't help thinking, but wow, with all these little simple mechanisms here, we've really gone quite far to describe how a ball of dust, something that looks just like this, could conceivably become a sun and some planets all around it that follow some of the many things that we see. So in particular, maybe if we can just remember together here some of the things that we've the nebular hypothesis has given us here. Definitely gives us the spin, gives us the flatness, it gives us the sun, it gives us rocky inner planets, and it gives us gaseous outer planets. I think also the size is a bit in there too, because the rocky inner planets, they are going to be smaller. And again, I'll just say that's because of the solar wind just would have blown a lot of material out of that region near the sun. And the gaseous outer planets here would have been larger, because all that material that was in the inner part of the solar system would have just got blown out there, and gravity could have would have and did bring it all together to form those larger planets like that. So at this point, the nebular hypothesis becomes a bit anticlimactic, because I realize that this drawing here is quite far along in the evolution of a forming solar system like that. But really, I think the picture that we're still at right now is that the sun would be here, and of course we have all that dust around the sun like this that's still doing its thing. And so I'm going to stick to the outside here where the H and the helium are, and the differentiated elements now, maybe the heavier ones, sort of would have been swirling in the inner regions like that. And of course we have the frost line delivered for us like this here, But of course now the question is, okay, well that's fine, but now how did the planets actually form? And I've never found a very overly convincing argument of how that actually happened, but we did have to sort of discuss this, and I showed you a video when we were discussing how the moon formed. And in that sort of scenario here, we might have had a rock like this and a rock like this that were just sort of passing by each other. Maybe this one was going this way and this one was going this way like that. But right here in this region, you know, there would have been a collision again, and as I described with the sun getting hot, same mechanism, some heat would have started to build up there, and maybe the rocks would have become a little more molten or something like that. And when they're molten because of their heat, maybe they start to become sticky. And I'm just, big question mark here. I've never been personally convinced of anything I've said or thought about this thing, but it could be possible then that a rock like this and a rock like this would then become go from two rocks to a larger rock like that. And of course, once they get larger like this, and I don't even know what scale I'm talking to, then of course the force of gravity can start to take over. So if there's maybe a third rock out here, that might sort of get pulled in this direction, force of gravity. Again, another collision and more heat, and maybe at some point this rock here that got pulled in by gravity slowly is just going to stick on there. And what do you have? Well, you have even a larger system here that just starts to get larger and larger and larger, and it even has a name. It might be called a planetoid at some point. And so what I'm going to do next is I'm going to show you some professional graphics about what this might have looked like, in particular these little lumps that would start to occur, which sort of became planets. And then maybe I have a video that sort of shows you what the composition of some molten rock might look like in terms of it being maybe a bit more sticky. Okay, so stay tuned here, and we've got some good stuff to show you coming up.